All right, we're going to introduce trig identities today. And we need trig identities because the next section we are going to do trigonometric proofs. Yes, you heard me right. We do proofs in trigonometry. All right, so let's get started. There are a total of 8 basic trig identities, and the first 3 are called the reciprocal identities. And they will look they're connected to the reciprocal functions. They look a little bit different. So we had talked about, we know that the cosine of theta is x over r, and then we defined the secant as the reciprocal r over x, all right? So that's not the reciprocal identity. The reciprocal identity says that the secant of theta is equal to 1 over the cosine of theta, okay? Likewise, the cosecant of theta is equal to 1 over the sine of theta, and the cotangent of theta is equal to 1 over the tangent of theta. Okay? So these are the basic reciprocal identities. Along with each one of them comes a partner that we could say, since the secant of theta is 1 over the cosine, it follows that the cosine of theta is 1 over the secant of theta. We don't use these ones as much, but they are also true, and it might turn out that you need one. So as far as memorizing, I would say definitely memorize the ones in the box, because again, these in this other box, let's say in the blue, let's see if I can change to blue. No, it's not letting me. Blue box, we can get them easy enough by simply flipping taking the reciprocals of the reciprocal identities. Okay, good. So those are the first 3. The next 2 are called the ratio identities. All right? And so I'm going to go ahead and develop them, and then you'll just have to memorize them. So here's what we know. We know that the sine of theta is y over r. Whoops. And we know the cosine of theta is x over r. And if we were to divide both sides of those equations, we'd get the sine of theta over the cosine of theta. Let's think about what happens when we take a fraction and divide by a fraction. What we need to do is flip and multiply, and look at that. Y over x turns out to be the ratio, right? And if that looks familiar, y over x is actually the tangent of theta. Okay, so that's the development. Here's what you need to know is that the tangent of theta can be written as the ratio, the sine of theta over the cosine of theta. Okay, so that's ratio identity number 1. Ratio identity number 2 says that since the cotangent of theta is the reciprocal of the tangent, it would follow that this is true. All right, good. All right, so we've got 5 down, we've got 3 to go, and the next 3 are called the Pythagorean identities. Okay, this is a little bit different. It's not exactly the Pythagorean formula. We get to the Pythagorean identities using the Pythagorean formula. All right, so again, I'm going to develop them, but your job will be to memorize them. So we know that x squared plus y squared equals r squared is the equation of a circle with radius r. And we know because it's an equation, we can divide both sides by the same amount. So I'm going to divide all 3 by radius square. And then I'm going to rewrite it because I can. This is from our chapter on exponents. You remember that distributing, we're allowed to distribute that power when we're dividing. And so r squared over r squared is 1. And then x over y, well, wait a second, that's just the cosine of theta squared, and this is the sine of theta squared equal to 1. And so there's our Pythagorean identity for trig. Looks kind of like the Pythagorean theorem, but this one has trig functions, all right? So what that means is that if I tell you the cosine of theta is 3/5, you can find the sine of theta without drawing a triangle, right? You can plug it into the equation 3/5 squared plus sine theta squared equals 1, and then you get 1 minus 9 25ths is 16 25ths, so the sign of theta is either going to be plus or minus 4/5. All right? So I just want to, before I go on to the last two Pythagorean identities, I just want to make a note, and that is we get tired of writing cosine theta squared. So math teachers, math people developed a shortcut because we know we don't want to just write cosine theta squared because that's not the same as cosine theta quantity squared. This is squaring the angle, this is squaring the cosine value. So we don't want to leave the parentheses off, but we get really, really tired of writing the parentheses. So here's what we do. The shortcut is that this is exactly the same as this. All right, so what we do is we put the 2, the squared, in between the cos and the theta. We say out loud cosine squared, oh, that's not what we say. We say cosine squared theta, right? And that tells us that we are truly squaring the cosine, not just the angle. Okay, so from now on, I'm not going to do that anymore, and you won't see it in your book as well. Okay, two more Pythagorean identities. Here we go. 1 plus tangent squared theta is equal to the secant squared theta, and 1 plus cotangent squared theta is equal to the cosecant squared theta. Now I didn't develop these, but I'll tell you that from cosine squared theta plus sine squared theta equal 1, to get to either of these is super simple, and you might want to try this after the video is off. If I were to divide through here everything by cosine squared theta, hopefully you can see that this becomes a 1, and if the sine over the cosine is the tangent, then it would follow that the sine squared over the cosine squared is the tangent squared. And if 1 over the cosine, back from our reciprocal functions at the beginning, is the secant, then 1 over cosine squared would be the secant squared. So these two theorems, these two identities, are really, really quite easy to get from the Pythagorean identity with cosine squared and sine squared. But like I say, we're going to use them over and over again to the point where you'll have them memorized, hopefully without too much effort. All right, I'm excited to get going on the identities. See you in class.